excited to have the opportunity to introduce him. Kelvin and I actually, many years ago, worked together at Chartered Semiconductor. So Mr. Kelvin Low joined ARM in 2017 as the Vice President of Marketing for a company's Physical Design Group, or PDG, with a broad-ranging experience in foundry ecosystem. Mr. Low is responsible for defining product strategy and roadmap, including managing products lifecycle from concept to sunset. Prior to ARM, Mr. Low held key product and technical marketing positions at Samsung Foundry as well as Global Foundries. Mr. Low started his career at Chartered Semiconductor as a process integration engineer. Mr. Low also had additional responsibilities as the market lead in the IBM Joint Development Alliance and the Common Platform. Mr. Low received his bachelor's degree in electronics engineering with first-class honors from the National University of Singapore. So without further ado, let's give it up for Kelvin Low.
So how's everyone? Let me make sure I can be heard. So I'm sure you're going to hear so much AI today. I think you'll be kind of overwhelmed by it. So I'm going to keep my presentation a little bit light and a little bit heavy, right? So while I was putting my slides together, so I will be talking about artificial intelligence welcoming the next lifestyle revolution. So while I was putting together my presentation, I thought how to make it fun, right? Playing my phone, actually just last night. So I used to check it out, the Google app. I say, hey, Brendan, congrats again for a great year, CASPA president, blah, blah, blah. Well done, right? What's interesting is the, if you notice, there's these three buttons below, right? It's like, hey, it gives you an option to say, thank you for your support, thank you, many thanks. I thought maybe this is kind of random. So I tried a couple of simple experiments. Right? I did it again. And in fact, I just arrived this morning from actually Noida in India, where I was actually visiting my ARM engineering site. So still stuck in transit, will be late today for the initial part, and then give another 3 things. So it looks like there is an algorithm running in the background, deriving context. Right? Tried it again, hey, some questions on CASPA membership, can you get some help? Sure, what's up? Yes, of course you can, or even no, sorry. So I think many of you may have taken this for granted. AI is already running today in many of our pocket devices, right? And this is just one example. But AI, I guess, means different things to many people, right? Smaller, but many common themes. Dr. Ma mentioned a couple of themes already. I'm sure my fellow speakers after this will mention even more. Things like automate, right? Analytics, big data, predictive, computing, cloud, and so on. But what does AI mean for me, maybe personally? So actually, I like a quote that I'm borrowing from Astro Taylor, right? Astro says that artificial intelligence, is AI, is a science of how to get a machine to do things that they do in movies. So I just have one slide to illustrate that. And this is actually quite interesting because many times, a lot of these innovations starts off in science fiction TV shows or movies. How many of you recall the show, Knight Rider, 1982, back then, an intelligent talking car. I enjoyed this movie. This is one of my favorite TV shows while I was in school. Right? Talks back, it has a very smart-looking dashboard. It has auto cruise control. It would be a wonder. At that time, I thought, wow, it would be so cool if I can own such a car, right? That can talk and that can have cruise control and what more can self-drive, right? So we know technology innovations today have made a lot of this possible, right? Today, our dashboard is interactive. We have a lot more cruise control, a lot more safety features that's already built in the car today. Another of my favorite movies, Minority Report. I don't know how many of you watched this. Movie was played in 2002, but the movie was set in 2054, right? While I was reading how this movie was made, in fact, a lot of the innovations back then, when the movie was shown, is already relative today in some form of fashion. Right? There was plenty of research that went into these movies. In fact, I read it was about 16 or 18 scientists that contributed ideas during brainstorming of what innovations can be showcased during the formulation of the movie. Two that I'd like to call out is personalized advertisement, right? So you can sense where you are, increase retail, or the probability of you buying something as you approach a store, for example. And I don't think this is far out from the future. Another one is a gesture control interface. We are starting to see some of this in the application today, but we'll be looking forward to what else we can see in the next years. Last one, maybe less well known, a movie called Chappie, is actually a police robot that had new programming algorithm built into it. It started not only to think, but also to feel, right? It shows, in the movie itself, it shows how it got closer by bonding with the human society. Right? So, interesting stuff, not far-fetched. Some of them are already relative today, and some will be relative in the next future. So, quick quiz. I don't know how many people know when was AI first defined, right? I was surprised when I, again, did the simple research, right? 1956, actually, by a professor, a mathematical professor, John McCarthy, Dartmouth College, right? He defines AI as every aspect of learning or any other feature of intelligence can be, in principle, be so precisely described that a machine can be made to simulate it. Right? So this was, from what I gathered, the first definition of AI, 1956. So it's not new at all. There are plenty of terminologies being thrown in. There's AI, there's ML, there's DL, there's NN, and so on and so on, right? So AI is artificial intelligence, essentially is the umbrella of any technique that enables computer to think or behave like a human being. Machine learning is a subset of AI techniques that involves training, inference, teaching, and then deep learning is a subset of machine learning, where then this multi-layer neural network that's being used to again be the foundation of machine learning and AI. I'll be talking a lot more higher level today around AI, not so much machine learning and deep learning. So brief history of AI. I talked about 1956, so AI is not new. So in fact, even before that, 1950, Alan Turing created the Turing test to determine machines' human ability, right? So AI was defined back 1956. In the 70s and 80s, there was what we call AI winters, where the industry actually had public interest kind of slowed down, investment kind of slowed down during those times. It did pick up in the 1990s. One key milestone back then was IBM's Deep Blue defeated Garry Kasparov in the chess game. 2009, Google developed self-driving cars. And then 2012, there's where there's a lot of the intelligent personal assistants, like Apple Siri, Google Now, Microsoft Cortana became really mainstream. Right? 2012, Google Brain, I think someone, my fellow speaker spoke about Google Brain just now, so it was developed. At that time, it was a task to identify text images on YouTube to a 75-degree accuracy, and that was 2012. 2013, in my talk later on, you'll see a little bit about China. So 2013, China's supercomputer Tianhe doubled the computing speeds, close to 34 petaflops. And then 3 years later, the Shanghai Taihu Light actually tripled the computing speeds to 93. And a couple more milestones there, 2016, a key milestone where Google DeepMind defeated the world champion for AlphaGo. And then more innovations around autonomous driving. So a couple of key history of AI. So multiple use cases today, and these are all real-life example use cases, from detecting plant diseases, people tracking using drones, smart surveillance camera at home, interactive robot for the elderly to keep them engaged, for example, right? Whether it's online gaming, video calls, etc. There's also to cover solving, I would say, application, or over here relevant to the Bay Area, health train detection application. More examples, there's smart inhaler that for asthma patients, where you can actually detect flow rate and other attributes to feed it back to the patient. And there's additional, of course, the Ranger camera. This is actually powered by solar. It actually reduces or helps reduces unnecessary or unwanted Ranger death. We're detecting Ranger images and feeding that into the train operators, right, real time. So why is AI so visible and so pronounced, right? Although this technology is not new, the innovations are not entirely new. Two key reasons. One is really the compute power or capability. So back in 2010, you could see that our compute capability was actually still minimal. Today, the compute density and compute power for devices allow us to process a lot more data at the right cost point. And then not only compute, data is also increasing tremendously. 2016, you're looking at 1 zettabyte. 1 zettabyte is like 1 trillion gigabytes. I don't know how many numbers are there. Right? And then come 2020, we're looking at 2.3 zettabyte, right, worldwide. The other interesting statistics, in China, we're also looking at the global digital information consumption increasing from 30% all the way to 25%. So we're looking at 9 to 10 zettabytes just consumed in China. So this is why the China government or the China is extremely aggressive and bullish, looking to leading the AI industry by year 2030. Right? They anticipate this industry to worth 1 trillion yen. There's about $150 billion. Don't get money back. Done in 3 phases. From now to 2020, we're looking at developing new AI theory and technology implemented in some devices and software. And the next phase, from 2020 to 2025, looking at major breakthrough in applications and expecting AI to drive the Chinese industry. And the last phase, till 2030, we're looking at deployment of AI, both transforming economics and industry in China. Why would China be successful in AI as an AI leader? Probably 3 factors from my viewpoint. One is the talent pool that exists over in China. Aside from many talents moving back to China, there's also a lot of worldwide research centers, Baidu in Silicon Valley, Tencent in Seattle, and so forth. Data is a necessary component. Dr. Ma mentioned about data. I'm sure fellow speakers later will talk about the importance of data to allow AI to be successful. So in China alone, 1.4 billion population, half of which are internet users, and these numbers will go up. Right? With data, there's also infrastructure that is being built aggressively in China, open source platforms, some examples there from Baidu, Apollo, and Pilot platform. That allows conducive environment to attract more talents and resources into China. So it is already, in fact, a lot of the business opportunities that we see, especially from startups and upcoming companies from China, are very, very focused around AI and machine learning. So to cite some examples here, Baidu, not only they are the biggest search engine, of course, they are already heavily participating in self-driving vehicles. They launched a fund last year, over $1 billion, to promote and to invest in over 100 automotive companies. On the consumer side, just at CES this year, for those who went, you probably may have seen this intelligent robot, family robot called Xiaomi Zhaijia, and it's actually running on their own OS as well. Alibaba, biggest e-commerce company over there, it also has the benefit of cloud services under Aliyun. One example I'd like to call out is the use of AI to train machines to detect lung cancer earlier through the image detection using high resolution CT scans. So this is a great use of AI. Tencent and then WeChat, we talk about using WeChat just to capture the QR codes. So not only WeChat is the largest or broadest social chat app. It's also a lifestyle tool. And Tencent has established an AI lab as well to look into new services and new products. Other product companies in China, iTech, renowned for its voice recognition capability. UBTech, a key player in robots, not only in as a consumer. We also have UBTech deploying robots in education as well as entertainment. McWing, AI facial recognition cloud-based provider. In fact, they have been doing this for some time. Back in 2012, they launched their first product called Face++, where they provide services in 3 areas, with detection, recognition, and also analysis. And some of these software are already being used for the payment platform by Alibaba. Last example here is Horizon Robotics. They're involved in developing chips that they call brain processing units, BPU, that is optimized for AI applications in high performance and ultra low power. So just calling out some examples. I'm sure there's many more that exist today. So a little bit switching over to ARM, we see ourselves as basically participating in many different applications, all the way from small sensors to the high-end servers, right? Just to show you some data here, in the last 22 years, from 1991, we shipped our first 50 billion devices. And in the next 4 years, we ship our next 50 billion devices. And with the proliferation of a lot of IoT end nodes, we expect the next 100 billion devices to ship in the next 4 years. Yeah. So we again anticipate ARM being able to reach out to many different areas of AI because of our proliferation with our partners. We have a view of AI. We actually expect AI to move a lot from the cloud to the edge. Right? A couple of reasons there. Bandwidth is one, where you see a lot of data, if you're being transferred from the cloud to the edge constantly, it could lead to lagging, right? And lagging can translate to unwanted user experience. So by processing a lot of this necessary data at the edge, it can actually improve on the user experience. Power is important. Processing a lot of this at the cloud actually consumes a lot more data center and server farms. Obviously, that is not good from a carbon emission profile. Some of this compute can be actually done at the edge. Cost is critical too, where we see that, for example, Google cited that if all Android users doing the voice recognition at the cloud, it will actually cost Google to spend 2x the compute investment. Latency, reliability, particularly important in automotive, and of course security, privacy as well is critical, right? Where you do not want data to transfer constantly, where you can at least expose you to data breach opportunities. So back in February, ARM announced Project Trillion. Essentially here, I just want to call out our new neural processing unit, machine learning based, constructed from ground up, that's optimized for machine learning and AI. Coupled with that is our object detection processor, and of course, on the software side, we also have the ARM neural network library. And then from there, we actually see ourselves as participating in this area to start, where our machine learning processors are capable of 4.6 teraops per second, with a power efficiency of 3 teraops per watt. We can scale this up over time in the server area, where then applications at 150 teraops per second can be enabled. So some examples of object detection here. For example, in a mall, you can actually for surveillance camera, where you can see where people are facing, directional, trajectory, gesture, and pose, all can be analyzed for safety features, for example. Some of these, again, have been already implemented in devices like the high security and high precision cameras. For those who like deep sea adventures, this is quite interesting. You can have a special diving suit, for example, special goggles with object detection feature enabled. For the shark, you know, if you are nearby, you want your anti-shark electric suit to be activated, for example. And then you can also analyze different images. CNN movie may be poisonous, only type gloves, and so on. I also expect this is not too far out, and it will help in getting the amateur divers to explore the deep sea even more. And then in smart city planning, all important as well, a lot of machine learning and object tracking can be implemented and probably already implemented. Pedestrian congestion, safety issues, all the way to finding a lost child, for example, right? And again, all of these are practical examples of how AI can touch on our human life. So, just want to conclude, we expect to see AI touching on all aspects of life, a lot of visibility in the areas of VR, MR, IoT, home surveillance camera. What we expect to see a lot more is also in the shipping and logistics area, medical area, to now benefit from the progression of AI. With that, thank you.
Thank you, Kelvin. I just want to do a quick survey on a technical subject that Kelvin mentioned earlier. How many of you have actually watched Knight Rider? Can I see a show of hands? Kelvin, you are too young to have seen that. That was my kind of show when I was growing up. At this time, I would like to invite Danny to present a token of appreciation to our speaker, Kelvin Low.